All right, let's talk about cloud networking. Think about the public cloud for a second. It's this massive, open territory where pretty much anyone can set up shop. But what happens when you need your own private, totally secure space for your apps? Well, you got to build a fortress, a digital fortress, completely walled off and protected from everyone else. The big question is, how in the world do you build a private fortress on public land? Let's find out.
Yeah, that's really the core problem we're going to solve today. How do you carve out your very own secure, isolated network inside a gigantic shared infrastructure like AWS or Azure? We're not talking about physical walls or moats, of course. We're talking about virtual ones, built entirely out of software. And that's exactly what we're going to do, step by step.
So here's our construction plan for the day. We'll start with the blueprint, the software that makes this all possible. Then we'll actually build our virtual walls and create different zones inside. After that, we'll post some guards and figure out how to control who gets in. Then we'll build the bridges and tunnels to connect our fortress to the world. And finally, we'll look at what's next for connectivity.
Okay, let's get to it. The real magic behind our digital fortress is that we're completely leaving behind the world of physical routers and tangled cables. In the cloud, our entire network is just code. It's designed, built, and managed with software. This is the foundation of everything, the software-defined blueprint.
The first piece of this puzzle is something called software-defined networking, or SDN. The best way to think about SDN is as the master architect of our fortress. It's the central brain that designs the whole layout, deciding exactly how all the traffic is going to flow without ever having to physically touch a wire. It separates the thinking, the planning, from the doing, the actual data moving.
So if SDN is our architect, what's it building with? Well, that's where Network Function Virtualization, or NFV, comes in. NFV is our virtual toolkit. It takes all the things you'd normally find in a big, clunky hardware box, a firewall, a router, a load balancer, and turns them into pure software. These are the virtual bricks and mortar we're going to use to build our walls and gates.
And here's where it all clicks together. SDN is the architect. It has the grand vision, the big picture plan, and NFV provides the actual functional building blocks, the virtual firewalls, the virtual routers that the architect uses to bring that plan to life. You really can't have one without the other to build a modern, flexible cloud network.
All right, our architect has the plans. We've got our virtual building materials. It is time to break ground. And the very first step in building a fortress is to stake our claim on the land and draw the outer boundaries.
And this is your plot of land. In the AWS world, we call it a Virtual Private Cloud, or VPC. Over in Azure, it's a virtual network, a VNet. But the idea is the same. It is your own private, logically isolated piece of the cloud. It gets its own private IP address range, and by default, it is completely cut off from everybody else. It's your own digital island.
Now, any good fortress isn't just one big open space, right? You have different zones for different purposes. That's exactly what subnets are for. You take your big VPC address space and you carve it up into smaller segments. So you can create a public subnet for your web servers, kind of like a public-facing courtyard, and then a totally separate private subnet for your databases, the secure inner sanctum that nobody from the outside can get to directly.
Okay, here's a little pro tip, a gotcha that you have to know. When you create a subnet, you don't get to use all of the IP addresses inside it. The cloud provider, AWS, Azure, Google, all of them, they always reserve the first 4 addresses and the very last one for their own networking magic. Things like the router and the DNS services. It's like the main gate and the building directory are already assigned. You just have to remember that when you're planning how big your subnets need to be.
So our walls are up and our zones are defined. But a fortress is pretty useless without guards controlling who can come and go. So now we've got to set up our security and define the exact rules for every bit of traffic moving around.
And when it comes to guards, you basically have 2 types you can hire. First, there's the smart guard. This is a stateful firewall. This guard actually has a memory. If he sees you leave the fortress, he remembers you, and he'll automatically let you back in when you return. You only need one rule. Then, there's the by-the-book guard. This is a stateless firewall. This guard has 0 memory. He checks your ID every single time you pass, whether you're coming or going. For this guard, you have to write explicit rules for traffic in both directions.
And here's how that actually looks in the cloud. Those smart, stateful guards, those are your AWS security groups. Think of them as a personal bodyguard for each individual virtual server. The by-the-book stateless guard, that's the AWS Network Access Control List, or NACL. This isn't a bodyguard, it's the security at the main wall of an entire subnet zone. You use the bodyguard for specific rules on a server, and the wall security for broad rules for the whole zone. Using both gives you an amazing layered defense.
Okay, our fortress is secure, it's organized. It's also completely isolated, which is maybe a little too secure. Now we need to build the drawbridges, the secret tunnels, and the diplomatic channels to connect our fortress to the rest of the world.
First up, the main drawbridge. This is your internet gateway. You attach one of these to your VPC, and just like that, any servers you put in your public subnet can now talk to the public internet, and just as importantly, the internet can talk back to them.
But hold on, what about those databases in the private subnet? They definitely need to reach out to the internet to get security patches, but you absolutely do not want the internet to be able to talk to them. That's what a NAT gateway is for. It's like a secure one-way door. Your private servers can go out, but nothing from the outside can come in. It is an absolutely critical piece of security. Now, what if you need to connect your shiny new cloud fortress back to your physical company headquarters? For that, you use a VPN gateway. This carves out an encrypted, secret tunnel right through the public internet. All the data that flows through it is scrambled and secure, making it look like your cloud resources are sitting right there on your local office network.
And one last thing, what if you have multiple fortresses? Let's say one for development and one for production. You need them to talk to each other, but you don't want that traffic going out over the internet. So you form a diplomatic alliance using VPC peering. This creates a direct, private connection between the two VPCs, and their traffic never leaves the cloud provider's secure backbone.
So there we go. Our fortress is built, it's secured, and it's connected. But the job is never really done. A good ruler always has to monitor their realm and think about what's coming next. And this is your security camera footage. Network flow logs capture information about every single connection attempt in your network, who sent it, where it was going, and whether your guards allowed it or denied it. It's an unbelievably powerful tool for troubleshooting connection issues or spotting suspicious activity. And the best part, it does all this without slowing down your network one bit.
And this all brings us to one final, really big thought. We've just built an entire, complex, secure network, and we didn't touch a single physical cable. It's all just code. So when your borders, your walls, and your defenses can be defined, deployed, and changed in a matter of seconds, what does that mean for the future of digital security? It's a powerful idea to end on. Thanks for building with us today.